If you think back to what we did last class, we worked on solving questions that looked like this. If we had 2 times the square root of x plus 1 equal to 8. Okay, how did we do this? What did we do first? Do y'all remember? I did it in red the whole time. Isolate. So to isolate the square root here, which is what I'm trying to isolate, you don't have to write this down, you can just watch. What would I be doing on this problem? What would I do to isolate? Yeah, underline or divide by 2. That means these 2's cancel out, and I'm left with just square root of x plus 1 equal to 4. Now the next step, I kept doing it in blue, and you guys just answered this on the Kahoot. How do you undo that square root? What do you do with both sides? You square both sides. Very good. And what that does is it just kind of gets rid of the radical, because radicals and squares are opposites, so they undo each other. And then we had one more step to be finished. In this problem, it would just be doing inverse operations to solve for x. So that would end up being x equal to 15. Now last class, I was always doing this like running joke where I'd be like, and we're done, or are we? Because what do we always have to do on these problems? Check it. Because there may be a certain type of answer. Does anyone know what it's called? It starts with an E. Extraneous. Yeah, the extra one that we have to throw away. But when we check this, all we have to do is put that number in for x and then type all of that in our calculator. And if we were doing this by hand, that would be square root of 16 times 2. The square root of 16 is 4. 2 times 4 is 8. So we are able to say that this one's okay. If that number doesn't equal the same number, then it's wrong and we throw it away. Do we remember doing this last time? Okay, we're going to be doing the same thing in 2 slightly different ways today. The first way is adding in some word problems. Now, it looks confusing and hard. It's written like an SAT question, but it's really pretty simple. It's going to be exactly like that example we just did. This problem says, in a hurricane, the mean sustained wind velocity in meters per second can be modeled by V of P equal to 6.3 times the square root of 1013 minus P. Go ahead and circle that. We definitely need that equation. Where P is the air pressure in millibars at the center of the hurricane. Estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. Again, sounds confusing because they're just making you read a situation where these sort of equations happen. But if you think about what we were given a velocity. Which of the letters used in my problem do you think velocity is? V or P? V. Okay, mathematicians name their letters things that make a lot of sense, like V standing for velocity. So what we're going to do is we're going to put 54.5 in place of V in the problem, or in this case, V of P, since V of P is just like a variable. And if we look at doing that, if we replace the V of P with that value, 54.5, we now just have a problem like I showed you on the first example right here, which means what am I going to do first to start solving for P? Divide by what? Because you're right, but divide by what? 6.3, because we want to isolate both sides of isolate the square root, we divide by 6.3 on both sides. So if y'all will help me out, 54.5 divided by 6.3 in your calculator. I'm thinking we won't do that one in our head. What do we get? 8.6, I believe 65? Yeah, let's go ahead and use that. 8.65 equal to square root of 1013 minus P. Cool. Did we follow the isolate step? Same as last time. What's the next step? Squaring both sides. Fabulous. So we want to take both sides, put them all in parentheses, and then square it. On the right side, the one with the square root, all that's going to happen is that our radicand, the stuff underneath the radical sign, is going to pop out. Because square root and square are inverse operations, so they cancel each other out. And then I just need to know what 8.65 squared is. 74.8, I believe it rounds up to 4? No, 2. Thank you. Good morning. Now we just need to solve for p. So how do I get p by itself? What's the first thing I should do to start isolating the p? Has something to do with this number right here. Yeah, we're going to subtract 1,013 from 7482. Yeah, that would be another calculator question because these aren't as like nice and pretty as the numbers we used last time. Negative 938.18 equal to negative p. Now normally at that point we were finished in our examples. Am I finished in this problem? Is it exactly equal to p? No. What do we need to divide both sides by? Negative, and we don't just leave it like a negative, we make a negative 1. But yeah, a negative, because we need the p to be positive for us to be done. And I just ran out of room, so we're going to come over here. So if I divide by negative 1, what is p going to be equal to? Yeah, the positive version of that number. And now since this is a real world problem, we like to give it units, especially if you're in a science class, you always have to give things units. And pressure, if you reread the blurb at the top of this, says pressure is measured in millibars. So we're going to call this 938.18 millibars. That's the unit used to describe pressure, bars, centibars, or millibars. No, we do. We're about to do that. That's a great point. Because again, with these types of equations, and in the real world problems, they're not going to be all that often that one of them will be extraneous, but it's always a possibility. So we are still going to check our work here. And that's the easy step because all we have to do is plug it in our calculator. We're just going to check and see if when we plug in 938.18 millibars into the problem, we get 54.5. Now I will tell you, we rounded these numbers, right? We had to round them. So when we plug it back in, it's going to be minutely wrong. It's not going to be 54.5. It might be like 54.3 or 54.2. That's going to be okay because we rounded this real world number. If you end up with like negative 54 point something, something is wrong. If you end up with something that's like 5 to 6 digits away, maybe go back and check your work. But if it's close and you know you've rounded the number, that's okay. Because rounding numbers will get rid of our accuracy. So if somebody could check that for me and let me know what we get just to see if we're close enough to call it good. We got something really, really super close to 54.5, didn't we? My calculator is telling me 54.49. Now that's definitely close enough to tell me that this is okay. I know I rounded this number, so it's going to be off when I plug it back in. That's why I prefer fractions, because if we had used fractions the whole time, it would be fine. But I digress. But every single time you do one of these radical questions, you're going to have to check your work because things can happen and they might become extraneous. Now, what's different about today, and the reason it's a different day is because we're going to be doing the same exact thing, but in a different way. That's a great explanation. So if you think back to when we learned about radicals, we learned that if we were actually taking the square root of 2, we could also rewrite that as 2 to the 1/2 power. Why? Where did the 1 and the 2 come from in the 2 to the 1/2 power? We had an acronym that helped us with this. This was before spring break, so I get it. We've slept since then. We had an acronym that we said numerator goes behind, denominator goes in front. So the numerator, which is 1, comes from behind the number. What's the invisible exponent back there? 1. And the denominator comes from the front. What's the invisible number here in front? 2. So when we have a radical, it can also be written as a fraction exponent. And we knew this at one point, we've just forgotten it. That's okay. Bless you. But what that means is our equations can sometimes be written not as the radical, but as stuff in parentheses with the power on the outside, and that power is a fraction. But don't worry, the steps are going to be very, very similar. The steps are isolate the term containing the exponent. That was the first step the first time, so that didn't change. Then it says eliminate the exponent by raising both sides of the equation to the reciprocal exponent. So instead of squaring both sides or cubing both sides, we are going to put that all in parentheses and raise it to the reciprocal. Now, what is a reciprocal? That's a great question. If the regular exponent was 2 over 3, the reciprocal exponent is 3 over 2. What did I do there? That's all a reciprocal is. So if you want to write that down for yourself, a reciprocal is a flip. All you have to do is flip the number over and you're good to go. The only way that gets tricky is if it's a whole number. What is the flip of 2? Yeah, it would be like putting the 1 underneath it and then flipping it. And that's truly the hardest it can get is if it's a whole number, because you have to remember to flip it to 1/2. And then the last problem is solve, or last step is solve, and of course our check. So it's the same exact steps as before. It's just the blue step is not always going to be a square or a cube. It might be a fraction. Can we try one? On to the back we go. Our first example today is like the first few examples from last class, so it's going to be pretty simple. Our goal to do first is to isolate the term with a power. We were isolating the square root a second ago. This time, we're isolating the thing with a power. You see how this right here, the x is tucked inside those parentheses and it has a power. That's what we want by itself, which means for this problem, what do I have to do first? Not divide it, but we do subtract 2 on both sides. So I'm going to do minus 2 minus 2. It gets rid of the plus 2 on the same side as the parentheses, and I'm left with 2x raised to the 3/4 power equal to 8. Okay, cool. I've isolated the thing with the power. The next step is to take both sides and put them in parentheses, just like I did before. But instead of raising it to the squared power or to the 3rd power, I'm going to raise it to the reciprocal power, which means I'm going to raise it to the 4/3 power on both sides. Where did I get the 4/3 from? Flipping 3/4. Okay, cool. Now it looks way complicated on the left side over here. But you do this specifically so that all of this stuff cancels out, and this is just 2x. Ah, that's much nicer. Now, 8 to the 4/3 power would be something you definitely do in a calculator. If y'all could please type in 8 to the 4/3 power. It's 16. Oh, that looks nice. And then we just divide. Very good. The last step is to divide by 2 on both sides so that we get x by itself. And x would be equal to 8. But just to ensure that this is not an extraneous solution, we do still have to check our work. Now we go back to the original problem to check our work, which means we want to check it in 2 times x, parentheses galore over here, to the 3/4 power plus 2 equal to 10. We want to make sure that when we type in that first side, with all those parentheses, got to have all of them, that it would equal to 10. I'll give you a second to try it in your calculator. Of course, when we type that in, the calculator tells us 10, and 10 is equal to 10. We're happy. We don't have to throw it away. It's not extraneous. Now, this is like the only level 1 question we have on these notes, because all the level 1s were like on the last notes. So before I move on to the other ones, do you have a question about the new blue step and how it differs from the old blue step? Or does that make sense to us? Okay. If not, ask me later. Because the next 2 problems on these notes are going to be a little bit more difficult. You can already see it coming because look what's on this page. Do y'all remember using that last time? Yeah. Okay, we're going to have to do the same thing here. So on this problem, we start with doing what? What's the first step always? Isolate. Do I need to isolate anything? Or is the thing with a power and a variable already by itself. Is there any number in front of it, behind it? No, it's by itself. Cool, I can skip the isolate step, done. For this problem, what's the reciprocal that I want to raise these numbers to? So if the regular power is 1 over 2, the reciprocal is 2 over 1. But 2 over 1, way too complicated. We're just going to make it 2, because isn't 2 the same as 2 over 1? Okay, fabulous. When I do this, the 1/2 and the 2 cancel each other out. Goodbye. It's just going to be x plus 30 equal to x squared. Now here's where your math spidey senses should be going off, because we just squared an x value, which means now we have a quadratic. The way we solve quadratics is with factoring, but we have to set it equal to 0 for that to happen. In this problem, we're actually going to move the x and the 30 to the right side instead of moving the x squared to the left side, because I don't want the negative to be on the x squared. So doing this in 2 steps, that's going to look like 30 equal to x squared minus x. And then finishing this out, we subtract 30 to both sides so that this becomes 0 equal to x squared minus x minus 30. Literally just picking up the x and the 30 and moving them to the other side. There were no like terms to have to combine it with. I just have to change their signs to the opposite. Now, if I want to solve a quadratic, I have to know what a, b, and c are. A is 1, check. What's b? -1, very good. And what's c? -30. So I have to go ahead and make sure I set up my x puzzle correctly. How do I set up this x puzzle? Y'all told me last time. Tell me again. What goes on top? A times c, which in this case wouldn't be exactly 30. It would be -30. What goes in bottom? -1. And what goes underneath my fraction bars? 1. Fabulous. So when I'm factoring, I just need to know the numbers that multiply to 30, but we're going to do it in an organized fashion, which means we're starting with the number 1. 1 times what is 30? 30. What's next?
3 times 10.
There's one before that one, but yes.
5 times 10. Oh, wait,
We're going to go in order.
2 times 15.
2 times 15. And then,
3 times 10.
does 4 go into 30? How about 5?
5 times 6.
5 times 6. Does 7? Oh, wait. I just skipped a number. 5. Then there's 6. 6 is already on my list. There's the whole list. Now, while I'm factoring this, am I going to add or subtract all of these numbers? What's the sign of the top in my x puzzle? Negative. So I'm going to subtract all of them. Is there one of these rows that's going to give me -1 when I subtract them?
1 minus 30.
Will give me -1?
Oh, -1. 5 minus 6.
5 minus 6. These are 1 digit away from each other. So if I use 5 and -6 as my values here, and I add them together, I'm going to get -1. So this is -6, and this is 5. So those are the numbers that I'm going to use as my factors to continue to solve this quadratic. It would be x plus 5 and x minus 6. Those numbers are from my x puzzle. Now, last time I did this part, I showed it in a whole bunch of steps, but I think we started to notice, I don't want to use the word shortcut because that's not fair, a way to do the math in our head. When we have these little terms, the solved version of the term, so if we have a factor, its solution is just the opposite sign. So what's the opposite of 5? Don't think too hard about it. -5. What's the opposite of -6? Boom, those are our 2 answers. So I'm skipping another little step, and skipping, again, really not the right word. I'm doing a step in my head because I'm connecting the idea of factors and solutions, which we've done before, you just forgot about. It's okay. When you have the number in parentheses and you want it out of the parentheses, it's just the opposite sign. Cool. But before I'm for sure done, what do I have to do? we have to check our work. So we go to the very beginning of the problem printed on the paper, which said x plus 30 to the 1/2 equal to x. But instead of x's, what should I be filling in? What should I be filling in here and here instead of x? -5. Okay. So we need, when you type in your calculator, -5 plus 30 raised to the 1/2 power. If that's not equal to -5, it's an extraneous solution. So go ahead, in your calculators, can you do that one for me? Let me know if it works or if it doesn't work. So if we get +5 when we type this in, are those the same things? No, so what do we call this one? Extraneous. So we do not use it as an answer, and I like to go ahead and cross it out when it doesn't work so that I can still see it. Like, I'm not going to completely like wipe it out because I want to be able to see see the answer I got in case the question I ask you on your quiz next time, which I will, is what is the extraneous solution? What is the real solution? So you still need to know what that number is. But we had a second answer here, so we need to check both of them. Let me give this one a little frowny face. We're sad. We also need to check if we plug in the other solution, which is 6, if that one works. 6 plus 30 is 36, and the square root of 36 is 6. So we're happy. That one's okay. So we can leave that one as an answer. So that was a lot, but we're just tossing in a factoring problem into the solving steps of solving for a radical. Again, the only new step is the blue step, which we've rocked. We know that. It's just putting it all together with other things that we know into one kind of problem. Yes? Yeah, go ahead. Okay, we've got one more, and y'all are gonna drive on this one. So you're going to have to tell me what to do each step. What's the first question you should ask yourself when starting one of these? Do we need to isolate? Okay, great. So, do we need to isolate? Yes. What do we have to move to get it to be isolated? The x. So we're going to add x to both sides so that these cancel. We would have x plus 12 raised to the 1/2 equal to x. Fabulous. What's the next question I ask myself? Something like that. We ask ourselves, what is the reciprocal that I need to raise both sides to? Which in this case is what? Yeah, we're going to square both sides. We're going to raise it to the 2. Very good. Because the reciprocal of 1/2 is 2. Once I do that, what happens?
The 1/2 goes away, and you bring down x plus 12.
Fabulous, yes.
Which is x. Same thing.
X squared, yeah. Okay, fabulous. So remember, all that complicated parentheses and powers cancel out. We want that to happen. That's like squaring both sides, gets rid of the radical, gets rid of all those parentheses, and we're left with this quadratic. Now again, we're going to have to factor to solve, but factoring requires that it's set equal to 0. And I'm going to do this like a quick little shortcut this time. I did it with the work last time, but really all we're doing is moving this and moving this to the other side of the equation. And what happens when things move from one side of the equation to the other?
It goes to the opposite.
Opposite sign, right? Fabulous. So without having to show all that work, I now have 0 equal to x squared minus x minus 12, because I just moved them to the other side. There were no like terms to have to combine them with, so I'm more easily able to do that in one step. Okay. What's A? 1. What's B? And what's C? -12. Those 3 numbers right there are going to help me do my X puzzle. Yeah, we're really good at doing this earlier. Okay, what's on top? Negative 12 on top because it's A times C. What's on bottom? And then what's the denominators? 1. I'm looking for the list of numbers that multiply to 12, but we're going to do it in an organized fashion. What should go first in this list? 1 times 12. What next?
2 times 6.
Fabulous. 3 times 4. Should anything else go on this list? No. Am I adding or subtracting this list? Why am I subtracting the list? What's negative? The 12. Yeah, the number on top is negative, so that tells me what I do with all these numbers. Fabulous. Well, here's the row that's going to give me negative 1. So my numbers are 3 and negative 4. Of course, those don't really reduce at all to anything when you divide them by 1, so they're nice and neat. These are easier factoring problems. And those numbers out of the X puzzle are what go into my parentheses, my factors. And then again, it's not a shortcut, so that's really the wrong word to use, but when I use the zero product property, what are the two numbers that X is equal to?
-3.
And?
+4.
Amazing, negative 3 and positive 4. Woo, cool. Last step is to do what every single time? Check. All right, cool. So we start with the original problem. And the original problem was x, which we're going to use negative 3, plus 12 raised to the 1/2. We're hoping, minus negative 3. We're hoping that's equal to 0 when we plug it in. Now again, this was x a second ago, and this was x a second ago, but I just plug a negative 3 in its spot. Go ahead and go to your calculator. Is all of this equal to 0? So this math sentence says 6 is equal to 0. Is that true? No, that's not true. So this is what kind of solution? Extraneous. So we go back up to our answers and we politely cross it out. Never mind, I don't want that one. We need to make sure 4 also works because there's a chance that both are extraneous anytime you're checking your work. So again, we plug in a 4. I'm going to go ahead and put everything in parentheses for good measure. Anywhere there was an x, this time I put a 4. And when we type that one in, what do you get? Yeah, on that one we do get 0, which is great because 0 is equal to 0. Hooray, we can leave that one as a solution. Okay, so that's how we kind of do that. That is how we do that. Isolate, raise both sides to the reciprocal power, and solve. Now the solving step might be the one where you have to factor, but y'all are following that pretty well. The solving step might also be easy like problem number 2 where it's not that bad.